All right, so we are in a new online IDE. I think it's probably made by the same people that made the previous IDE I was using, but now it's in black and it says online Java instead of saying online IDE. So I guess it's made specifically for Java. Maybe this one was made first, maybe the other one was made first. I don't really know. But I'm going to copy some code that I had already written. There we go. And this was that prime number generator that we did in the last video. So let's run this and let's see what's going on. At the moment, it's just going to prompt us to enter a number. Can say, okay, 500. And then it generates all the prime numbers here, all the primes below 500. 2, 3, 5, 7, 11, 13, going on all the way to 499, which is apparently prime. Cool. So I thought what would be kind of interesting, because we have a prime number generator at our disposal, there's a number of different things that we can investigate involving primes, because primes are not very well, the distribution of prime numbers is not very well understood in the mathematical community at large right now. And so what comes to mind is Goldbach's conjecture. So let me go up here in a comment and let me see if I can talk about Goldbach's conjecture. Now, this is still an unsolved problem in all of mathematics. And what it states, it's just a conjecture because we haven't proven it. That's what I mean by unsolved, is unproven. It says that every even number can be, I don't know why it's giving me suggestions about things to use when I'm in a comment. This is a weird IDE. Every even number can be expressed as the sum of two prime numbers. And we're pretty sure that that's true, but it's never been demonstrated mathematically in a more theoretical sense. So we're definitely not going to do that here. But what we can do is we can kind of explore it a little bit. So now that we have prime numbers, we can grab a list of them, and instead of just printing them to the screen, we can maybe put them into an array or something like that, a list object of some sort, or we can just sort of see what we can do here. Now, I was thinking about Java and its encapsulation, and I was thinking about creating a whole new class which outlines a new object which we can then create instances of and work with. But then I was thinking, I think I can do all of this using a more just procedural, functional approach, meaning using functions, which in Java are known as static methods, where we can take in parameters as input, do some work with them, and then return a value. Note that we cannot pass any values in by reference, so that any parameters, any values that we pass in here cannot be modified and then be useful in our main function, in our main method. Okay, so what are we going to do? Let's look at adding up prime numbers, tracking their sums, and then just seeing what they look like and see if we can maybe generate every even number by just adding up primes. Now, that's not the same. I want to note that's not the same thing as what Goldbach says, because what Goldbach says is every even number can be expressed as the sum of two primes. It does not say that every time you add two primes, you get an even number. Think about that for a second. It's a logical fallacy of implying the converse if you think about it in that way. When you add up two primes, it's absolutely more than likely that you're going to get an even number because most primes are odd. When you add an odd plus an odd, you get an even. So just by adding up primes and seeing what our list looks like, if it looks like it's generating for us every single even number, then we have a little bit of evidence to support Goldbach. So let's just see what happens here. Again, this is one of those videos where I'm just actively coding as we go. So instead of printing out all these primes, let's get rid of this code, but let's kind of comment it out. so that it's still there, but it's not being read, it's not being used. So that's all commented out. Good job. Okay, cool. Okay, here's what we might want to think about doing. Let's get another for loop going of, let's generate prime numbers. So we'll loop through primes. So we'll start with, did I use K already? All right, let me use I don't know, A. I'll just go A, B, C, whatever. A starting at 2. Loop. Let's get that pre-established value, right? So this enter a number. Let's make that a maximum, but in the fact that we're gonna only look at numbers up to that point. So let's go with A is less than or equal to num, A plus plus. So we've set up a loop to go through numbers from 2 to num. Of course, we want to just focus on the primes. So we will use if is prime of A. And I'm purposely opening up braces because that's a good technique to do if you're not sure how many statements are going to be inside, following in your little clause of code. So I can get rid of them later if I want to, but for now I'm going to put braces on everything. So if is prime of A, what do we want to do? Well, how about let's have, I want this to print to the screen in kind of a clever way. By the way, I made a static import statement here for the system class, so I don't have to keep writing system dot. I can just write out dot. So out dot print line, or out dot print, and let's list the number A, right? And then we'll say plus, we'll actually put a plus sign in there. This is weird with concatenation. Thank God for different color codings. Let me leave it at that. Well, actually, let me put this inside of the if it's prime, then we'll print it, and then we'll print a plus sign. What we're going to have to do here is we're going to have to make another inner loop. So let's again start with, let's do B. B starts at 2. B will be also less than or equal to num. I'll show you what we're doing there in a second with that. B plus plus. And let's now give the right-hand side of this summation. We'll print out, let's start with the empty string, because then it gets weird with the pluses. Same thing up here, empty string plus, okay. Concatenation can get a little weird. Plus this. And if we're doing it like that, we can go ahead and put what, equals, right? We're kind of looping. Well, actually, I only want to test primes here too. So if is prime of B, hopefully this makes somewhat sense. It does in my brain. We'll see what happens. Boom, out to print. Okay, so it'll loop again, and it'll have the right-hand side of our. Let's put a. No, we don't need a space, do we? Guess not. That does need a semicolon. Then we'll print B equals, and then we'll also out dot print the sum of A plus B. You know what? We might want to start a list of those sums. So I might want to put that somewhere. I'm not going to worry about it too much right now. So there is two statements here, so I do need the braces. Let's keep braces going throughout this whole thing. I'm looking at this program and I'm thinking about it as it's going to start looping up the left-hand side of our, equals thing here is going to loop from 2 to num. Then it's going to go through and only look at the primes. If it's prime, it's going to print it. Then it's going to look for another prime in 2 to num. It's going to add those two together and it's going to print the result. I think after we do that, we'd also want to print a new line character. Actually, I guess I can do that by just putting print line up here, huh? That's closed, that's closed, that's closed, that's closed. Let's see what happens. I want to put a relatively small number because it's going to be looping a lot. So let's say 10. Ooh, snap. What happened here? So I put in 10, and then it starts. Okay, it's not doing that right. It does start 2 plus 2 equals 4, and that's good because that's 2 is the first prime number. I was expecting it to then fixate on 2 here and go to 2 plus 3 equals 5. It's not reprinting. Oh, well, yeah, I guess here we want to print the entire thing. A plus a plus plus and equals plus b. This is starting to look weird now. But I want to get it out of here and put it into the innermost loop, I guess. Empty string plus a plus a plus plus b plus equals the sum a plus b. Let's see, 10. So 2 plus 2 is 4. 2 plus 3 is 5. So it is doing what's expected. It's fixating the left-hand side on 2, and it's looping through all the other primes, 2, 3, 5, 7. And it is generating our sums as 4, 5, 7, 9. Those are actually all odd, but that doesn't prove or disprove anything. We move on to 3. 3 plus 2 is 5. That's odd. But then every single other number here should be even, unless it involves the number 2, because 2 is the only even prime number. So we have 3 plus 3, 3 plus 5, 3 plus 7, 3 plus 5 plus. So if we look at this side, this list here it's generated on the right, we're getting some even numbers, some odd numbers. The point is we should be getting every single even number possible. So do I have 2? I should probably clarify. 2 is not involved in Goldbach's conjecture. I think it's every even number greater than 2 can be expressed in some of 2 primes. So 4 we have. Then we have 6. If it's in our right-hand list, it works. Yes, 3 plus 3 is 6. Was it 4, 6, 8? That's the 8 right here. 3 plus 5. And then 3 plus 7 is 10. So I have 2, 4, 6, 8, 10. 12 right here, 5 plus 7. 14 is 7 plus 7. So I've gotten some good results so far in generating even numbers given primes. Now I only went to like 10 by 10. If I go a little higher, let's go up to like maybe 50 for the left-hand and right-hand side. Now I have a much larger list. See if I can scroll up. Yeah. So I got 2 plus 2 is 4. And it ends up going all the way down to 47 plus 47 is 94. And as you can see, we'd have to go through all of the results of a plus b and see if that is every single even number. So we can actually do that. That shouldn't be too much of a problem. If we store, all right, let's make a variable called sum, we'll give it 0, integer. Let's get rid of this because I don't think we're going to need it. So let's have sum get a plus b. Then we'll go ahead and print sum. That shouldn't change anything. But now we've stored that value into this thing called sum. What I'd like to do is put sum into a, I was going to say an array or a list, but I actually probably want something more like a set. A set being something that if something is already inside of it, it won't add it in again. But I think a set might be an abstract class. I think you have to either have a, what is it, like a tree set? Don't know too much about sets here, but I do have the sum stored into a variable. Oh, no, what I really actually would like is an array, right? An array of sums. Can I just initialize like that? No, I have to say gets new int and then give it a size, I think, because arrays are not. Damn. I don't know. Let's just say I give it a size of 1,000. Then sums are sum at k, and then we'll have to, every time we compute a sum, we'll have to increment k. Every time it computes a sum, it tosses it into, and then isn't there a way to print an array? Like, let's do out.print sums, and we'll print, can we just print the array sums? Or is there an arrays.toString? Is that a thing? No. What if I just print the array sums? Does that actually print? Or let's just print it then. Let's just use a loop to print it. What am I on now? C? C is less than sums dot length C++. No pun intended. Out dot print empty string plus sums sub C plus a comma and and see if it'll print all the sums for me. Sum of k, but I need to increment k. What if I do sum of k plus plus? Does that work? Is this like C? Can I do that? Right. It's probably because it's called sums and not sum. Because I never declared it, did I? So where do I declare that? Right up here? And k starts at 0? Hmm. Yeah, well, I don't. Maybe sum at k? This might not do what I think it's going to do. Sums at k. See what that does. All right, no syntax errors. Let's, again, just, oh, wow. Okay. Well, okay. That's not bad. So I entered at number 10. It's giving me zeros here, which is odd. But then for the sums, give me 4, 5, 7, 9, 5, 6, 8. So it does seem like it's storing the sums. And then the zeros are just there as padding because I made it like 1,000 thing array. But if I go up to like 50 like I did before, it's going to fill up with more values. It sucks that these are all printing a 0. That's kind of dumb, but it is grabbing those sums. 4, 5, 7, 9, 13, 15, 19. It's not grabbing them in any particular order. So then from there, I have to kind of order the array and maybe have to sort it. But it is grabbing all the sums of the result when you print basically every prime number up to a given point. See if we can make this think for a little while. How about if I feed it in, I don't know, 75 is an upper bound. And so already thinking a lot. 75, there we go. So we still got some zeros here in the padding, but now my sums are going up to, you know what? I think there is actually an arrays.sort, isn't there? I feed that in my sums array, have it sort. That'll probably put the zeros at the beginning though. Arrays.sort? I thought that was a thing. Do I need to import something for that? Java.util.arrays, probably. Let's see where this is going. 75. Ooh. Oh yeah. I thought it filled the entire array, but I forgot I had all those zeros. So this is obviously not printing the sum correctly. Sums at k. This is incrementing correctly, but yeah, it's just not printing right. So let's just print a plus b to make it more explicit. Let's make it go even higher. Shit. I mean, 120. So again, to enlighten everyone on what's going on, it's fixing my left-hand side of the addition to prime numbers from 2 to 120. Then it's iterating through every prime from uh, 2 to 120. For the right-hand side, it's adding all these things up, and then it's storing all of these sums that it's grabbing into an array of integers that I made called sums, and it's printing out the value of all these sums. We're trying to show that every single even number basically is in that list of sums, or at least up to a given point, because of the limitations of computer memory. And again, this is probably not the best or most efficient way to do this. It's just something that I thought of on the spot. So in my array of sums, I do have a bunch of zeros, but and they're in order now because I sorted them. So I have 4, then 6, then 8, 4, 6, 8. I'm looking at every even number. 10 is in my list, 12, 14, 16, 18, 20. And I can clean this list up a little bit more by just deleting the elements that are not even and deleting repeated elements. I've got the number 10 that came up twice. I got the number 14 that came up 3 times. So I can clean this up definitely and make it look a little nicer. And I think that given, up to a certain point, we can demonstrate that Goldbach is consistent, at least up to a given point. And again, this is by using a computer, by using our prime functions that we built before, and by creating a list of these integer sums. And that's a pretty interesting little exploration into how to use programming for some mathematical uh, investigations, if you will.